Okay, Bismillahirrahmanirrahim. So today our topic is, it's one of the most important topics as far as the objective type exam, CSR, NET, GATE and related exams. So the exercise में question आता है बहुत important है actually rule it's called as a Woodward-Fieser rules. तो Woodward-Fieser rule जो है basically scientist का नाम है उन्होंने एक rule दिया है इस rule में होता क्या है that we calculate the हम theoretically calculate कर लेते हैं we calculate the absorption maximum of molecules. So now we calculate the absorption maximum जो हमने पिछले लेक्चर्स में डिस्कस किया था absorption maximum of molecules. हम लोग ये theoretically calculate करते हैं on the table पे बैठ के घर पे बैठ के just open the book and apply the rules, you can theoretically predict the absorption maximum of molecules, organic molecules. Absorption maximum से मुराद जैसे हमने last week कहा था that's the, so we'll calculate the lambda max. और देखा ये गया है कि the lambda max which we will calculate with the help of the Woodward-Fieser rules, that is almost similar, it is very closer, sometimes almost same to the experimentally calculated. जो हम इंस्ट्रूमेंट से जो हम सैंपल का लेते हैं उसी सैंपल का हम theoretically calculate कर लेते हैं so that those are very closer. So the value obtained is almost similar to the, are very closer to the experimentally obtained values. So this is what we know by the what we know actually in general about the Woodward-Fieser rules. Okay, now Woodward-Fieser rules के लिए application के लिए how we calculate this. First of all, we'll try to understand some basic terms here. So by Woodward-Fieser rule, we can calculate the absorption maximum or lambda max of molecules. Now first thing, उसमें first part is dienes. Now, dienes. जैसे हमने एक लेक्चर में रिकॉर्ड किया था dienes में कि those molecules where we have two double bonds in conjugation, they're called dienes. So this type of fragment present in the molecule, one and one double bond by this is alternate single bond, so it's called conjugated dienes. Now ये तो एक हो गया conjugated dienes. Conjugated dienes में ये cyclic भी हो सकती हैं और acyclic भी हो सकते हैं. Acyclic भी हो सकते हैं और they can be the acyclic. जैसे ये है this is acyclic diene. अब cyclic का जहां तक ताल्लुक है cyclic can be in this form. Let us take the example of now ये हो गया आपका diene. देखिए this, look about this fragment. So this is present inside the cycle. ठीक, it's called cyclic. ये इस फॉर्म में भी हो सकता है आपका एक रिंग है उसमें दो बॉन्ड्स है. It can be in this form also. के पास दो rings are present. Two rings are there, so it can be in this way also, that you have ring attached and then you have butadiene. So it can be this form, it can be in this form. Fine. So that means if both the double bonds are attached in a single ring, they are in a single ring. So this type of system we call as homoannular conjugated diene. Homoannular. Annular means ring. Annular conjugated diene. तो एक important चीज में याद रखनी है conjugated diene. Cyclic में we can be in this form or this form. When both the double bonds in conjugation are inside the ring, it's called a homoannular conjugated diene. दूसरी situations में ऐसी भी हो सकती है. Next situation क्या? This is situation number 1 in the cyclics. So this was the acyclic. Situation number 2. If you have a system like this, so we have a bond here, a bond here. देखो, now this is double bond. Look at this fragment. It's a butadiene fragment. Double bond, single bond, and double bond in conjugation. But now the bonds are present in different rings. That's why it's called a heat. So they are present in different rings. Fine. Yes, it was like that. It can be in this form also. But the criteria है कि they should be in the conjugation. We are talking about that diene. याद रहे यहाँ पे. So first class of compounds trying to understand the Woodward-Fieser rule, that's the dienes. So आज के lecture में we'll deal with the dienes. First of all, we will understand the basic terminology. So it can be like this. अब देख लीजिए. They are in the conjugation here. So your double bond, single bond, and double bond. So this is also the diene. अब ये दो rings में अलग-अलग. So it's again this type of structures. So it's known as the heteroannular dienes. This type of diene. Heteroannular dienes. So this is all of the homoannular dienes and heteroannular dienes. Now there's some more terminology involved before we shift to the calculation part. So this is the homoannular and heteroannular diene. Now let me make a ring here again. एक ring मैं बना लेता हूँ यहाँ पे. ठीक. Now if we have a bond like this, ये दोनों bonds inside the ring है, so we call them, they're both the bond, they're endocyclic double bonds. Fine. Endocyclic inside the ring. Endocyclic double bond. The situation can be like this also. Let's draw one more structure. Now अगर आप इसको देखोगे structure को, this double bond, it's in conjugation with this. Again double bond. ये वाला इसमें ये जो double bond है, it is present inside the ring. So this can be called as endocyclic double bond. Endocyclic double bond. And this is outside the ring. It's called as exocyclic. Exocyclic double bond. So now the bonds can be exocyclic, endocyclic. Fine. So इसी तरह से जो हमने एक सिचुएशन यहाँ पे बनाई, देखो, if you look at these two double bonds, for this ring, this double bond is exocyclic, and for this ring, this double bond is exocyclic. For this ring it is endocyclic, for this ring it is exocyclic, whereas this double bond for this ring is endocyclic, but for this ring it is exocyclic. So this way we can actually look at the the basic terminology involved in the dienes. Now we'll start calculating how. Okay, we'll shift to our main topic. ये तो होगी main चीज़ है, क्योंकि these are very important once we look at the calculations later. So this is our part number 1. We'll starting dienes. So हम करते क्या? So what we'll do? So remember that first of all, हम लोग butadiene system को, ये जो system हमने बोला था, दो bonds in conjugation, whether they are homoannular form, they are in the heteroannular form, whether they are exocyclic, they are endocyclic, whatever the way they are, we make this as a base unit, a basic unit. So we are making here the step number 1, butadiene as a base unit or basic unit. ठीक. तो जहाँ भी हमें कैलकुलेट करना पड़ेगा, हमें फर्स्ट सर्च करना पड़ेगा उस मॉलिक्यूल में whether there is this type of a butadiene present, conjugated. ठीक. So this is our the basic unit. अब हमें पता है कि basic unit का इसका absorption कितना है, that is 217. तो remember it is lambda max, that is absorption maximum 217 nanometers. Now this you have to remember. Butadiene lambda max 217. उसके बाद हम मॉलिक्यूल में अगर हमने ये चीज सर्च की तो ये हम बेस मान के चलते हैं. उसके बाद उस मॉलिक्यूल पे कौन से सबस्टिट्यूएंट्स अटैच्ड है, व्हाट आर द डिफरेंट फ्रेगमेंट्स अटैच्ड ऑन दैट ब्यूटाडाइन सिस्टम, उनका कंट्रीब्यूशन हम 217 को ऐड कर लेते हैं. फॉर एग्जांपल इसको अंडरस्टैंड करने के लिए we'll take an example. So the point number 1, we are choosing butadiene as a basic unit or a base unit, and its absorption is 2017. Let's take an example. एक मॉलिक्यूल है इस तरह का, डबल बॉन्ड. ये जो बॉन्ड्स है these are जो मैं दिखा रहा हूँ, these are CH3 system, CH3. So जो इसमें मैं दिखा लेता हूँ, आगे will not write, so it's CH3. So this is proton, and this is again CH3, this is again CH3. Now this is a molecule, fine. We'll not worry about the name of the molecule. This is a molecule. अब देखिए, so what is the lambda max of this molecule? So we have to calculate the lambda max of the molecule. We have to calculate that. So what is that? So what we will search first whether there is a butadiene system. This is carbon. Okay. So carbon, double bond. So this is a butadiene fragment here. So we'll write. We have butadiene unit present. So its lambda max is 217. Fine. 217. So this is the lambda max is 217. यहाँ पे एक तरफ से करेक्शन करना है, जो नैनोमीटर है, instead of this, so we are taking this as micrometer. ठीक, so we're using because Excel books में जो है calculation के से have used micrometer, so this is micrometer. So this is so please take care of the unit. This is micrometer. ठीक. So we have searched that in this molecule we have presence of butadiene system, and its lambda max is, as we already know, is 217 micrometer. Now, अब देखिए इस पे कोई substituent है, यहाँ पे एक proton that cannot be called as a substituent, hydrogen. So let us forget it. Substituent means now we have methyl group here attached to this double bond. We have methyl group here. यहाँ पे दो methyl groups 1 and 2. Now the contribution of a methyl group or alkyl group. So contribution of alkyl group इसमें. So rule number 2 here. इसमें we have to add contribution of alkyl group. Alkyl. It can be methyl, ethyl, alkyl group. So alkyl group will contribute 10 micrometer. Alkyl group can be methyl, ethyl, propyl and so on. इसका contribution कितना होगा 10. So we'll add here हमारे पास कितने ग्रुप्स है 1, 2, 3, 4. So contribution of alkyl groups. कितने ग्रुप्स है 1, 2, 3, 4. 4 into 10. That is 50 micrometer. Fine. That's 50 micrometer. So और कुछ है और कुछ नहीं molecule में. So we'll add up this. 217 plus 50, that is around 7. And this is 6. So the lambda max for this compound is calculated to be 267 micrometer. बहुत आसान. Okay, I'll take one more example. अब इसी system को मैं यहाँ पे थोड़ा सा I'll make it slightly different now. So, okay, so this is one example. So rule number 1, that the contribution of butadiene is 217, and if the alkyl substituents are in the group, so each will give contribution of 10 micrometer, right? I'll take few examples for the understanding. अब मैंने क्या किया, I will make this as a cyclohexane ring. So we'll start calculating. So we have butadiene present, so butadiene contribution is 217 micrometer. Fine. Now, अब यहाँ देखो, अब if you look at this ring, पहले we look at alkyl substituents. How many alkyl substituents are there present? Fine. Up this is one alkyl substituent, and now two alkyl substituents. So contribution of alkyl substituents, that is 2 into 10, that is 20 micrometer. अब देखिए, अब ये रिंग है ना, दिस रिंग, this double bond, it is exocyclic to this ring. अब आ गया एक exocyclic double bond adjust to the ring. ये exocyclic है ना, even though it is from butadiene, but this double bond is exocyclic to this ring. Now the contribution of exocyclic. So here we'll write point number 3. If we have exocyclic double bond, so that will contribute. Alkyl was 10, exocyclic double bond, so that will contribute 5. ठीक. So rule number 1, butadiene base 217, alkyl substituent contributes 10, exocyclic contributes 5. So we'll do the molecule now. So we have contribution of exocyclic double bond. So that is एक ही है, so 5 micrometer. Fine. और कुछ नहीं है present. So we'll add up these all 17, 25, कितने हो गए 25, that's 242. This is the calculated lambda max of this molecule. So इस तरीके से आप कर सकते हैं. Okay. तो ये तो हो गए 3 points. अभी और कुछ हम एग्जाम्पल लेंगे that we can try to understand the any more example if I have. Okay, we'll try one more example. इसमें examples ज़्यादा important है. From that we'll easily understand. Now, if you have this type of molecule, example number 3. ये examples आप note कर लीजिए. These are very important. ये CSR में भी आती है, NET में भी, GATE में भी. PG exams. We asked in all exams. So these are two cyclohexyl type rings. Now this is the molecule. So we need to calculate the lambda max. कैसे करेंगे? So we have butadiene here. This is our butadiene. So your butadiene contribution. Do like this. Butadiene contributes 217 micrometer. Fine. 217 micrometer. Now, अब हमारा जो क्वेश्चन है जो बहुत ही इम्पोर्टेंट है, the ring, अब हमारा जो exocyclic rings का सिस्टम है, that's बहुत important, that the types of rings we have. So exocyclic तो है नहीं. अब ये जो रिंग है, ये इस डबल बॉन्ड पे this is considered to be one substituent, this is considered to be another substituent. Likely ये जो डबल बॉन्ड है, this is ये attached है ना, this is another substituent and this is another substituent. So there are 4 alkyl, this is there are 4 the 4 ring residues उनको हम कहते हैं. ठीक. So there are the 4 ring residues. Ring के अंदर special substituents है 1, this is 2 on the double bond, this is 3, this is 4. इसमें 4. Now इनको हम कहते हैं, we call it the ring residues. So now we are reach a point. If you have a ring residue present, ring residues, it's called a ring residue. So the contribution is 5 from each. So यहाँ पे कितने आ गए? 4 ring residues. So 4 ring residues. Contribution from ring residues. That is 4 into 5. 4 और each का 5, that's 20. So turns out that your lambda max is equivalent. इसको ऐड करेंगे तो how was that? यहाँ थोड़ा सा base value is not butadiene, sorry, base value it's not a butadiene, it's basically अगर देखो दो रिंग्स में डबल बॉन्ड से heteroennular diene, sorry, so this is heteroennular. So हमने कहा था ना कि दो रिंग्स में डबल बॉन्ड scattered, it is like this type of a system. वो यहाँ थोड़ा सा slip here and here, this type of system. Look at दो अलग अलग रिंग्स में, so it's heteroennular ring. तो इसका कंट्रीब्यूशन होता है 215. So heteroennular ring. तो heteroennular ring में अगर आपका डबल बॉन्ड है, that is 215, not 217, 215. So it turns out it is 35. So this is one example. Now यहाँ पे और एक पॉइंट आ गया कि ब्यूटाडाइन के साथ साथ अगर आपका ब्यूटाडाइन it is present in the form of heteroennular. So इस ब्यूटाडाइन का 270. Now if it is as heteroennular form of butadiene, so its contribution is 215. ये देखो तो ये 2 नैनोमीटर कम, sorry, 15 micrometers, fine. यहाँ पे if it is this type of system, cyclic open chain, it's 217. If it is heteroennular the ring, that is 215, fine. Okay, then we can take some more example and we'll try to some more examples of compounds. So, okay, so what we have done today, the lecture number 1, if you have to calculate the lambda max, we have to first search if we have a butadiene system like this, acyclic type. The contribution of the base unit is 17. Now if it is heteroennular means if it is this type of system. Double bonds are present in conjugation but in different rings. Then the contribution is 215 of the base unit. Now if you have substituents present, alkyl group, so its contribution is 10. It can be ethyl propyl. If it's exocyclic double bond, contribution is 5. If you have a ring residue, contribution is 5. So these contributions will add to the base unit, this or this, and we are positioned to calculate the lambda max of the molecules. Now we'll do tomorrow some more examples related again to this butadiene system, so that our concept will get clear. So this is all for the day. So please note all these examples and these rules.